good amount extra, which is kind of nice because you can build some other stuff too. But what we end up doing here is we know we have 8-foot doors in the center, which are in those 2 crates over there.
They come with it?
These came with it, yeah, but it's a different, you have to tell them you want that kind of door. So those are 2 can doors that roll up like a garage or like a storage unit style would. They're got a little bit of insulation in them. They ride in a track and then roll into themselves. So I'm gonna look again before we go ahead and set the verticals, but I think for those ones, they want it to be exactly 8-foot opening. Sometimes like when you frame out like for a house door or there's another person door, we'll probably, you'll frame out a little bit wider for the rough frame for it, and it'll sit in a frame inside there. So before we cut and do that, we're gonna open one of those up and look at the directions again. And then, otherwise going off here, it's kind of like you can do whatever you want to do, and we try to make it look nice. So we're moving stuff around. It ended up being, we wanted to put 2 verticals in here, but they send more than enough steel. We could just put 1, but it's like, let's put 2 and just be safe and be strong. So we took, this distance here, ended up being 11 feet. We could do equal distances. What we end up having is 3.5 feet here, 4 feet here, and 3.5 feet here. And then we just did the same thing on the other side. So this is going to be where our verticals run. And then for the poly that they send for the end walls, they used to send it cut, and you would do it in 3 strips like this, but it only comes in 12-foot width. It's woven stuff. That's as wide as the machines that the poly companies have to make it. So what ended up happening is if you had an 8-foot door, you needed 11.5 feet for the verticals. You ended up putting vertical here, and then you ended up putting a vertical like right here too, and the same thing on the other side. So what they've suggested now is that instead of putting 11.5 foot space this way, that we're going to come in and put some horizontals in. So they say just cut it and put a horizontal at 11.5, and then instead of putting the poly on this way, we'll turn it. So there'll be one piece going like this up to 11.5, and then there'll be another piece up above that will screw into our 11.5 as well. So they'll overlap, get screwed together. And then there's a channel that we'll end up putting on the top as well, that the top of that one will lock into, and then the top of the polyethylene for the whole house will lock into that same channel. So instead of having 2 layers of poly and 2 layers of wiggle wire in there. And with the woven poly end wall, it's warranted for 8 years, the woven poly. So what we end up doing is putting that one in first, and then putting the roof poly on top. So that when you change out the roof poly, you don't have to take the end walls off. If they're both, 4-year poly, it really doesn't matter. You're going to probably replace them at the same time. I still like to put the end walls in because they tend to break down more slowly than the roof. So what we'll do is probably we'll put some verticals in. We'll put our horizontals across the bottom, and when we line that sheet up, I think it's that 12-foot wide one. So we'll have a little bit of overhang, and we'll also have a little bit of overhang down here. So we'll have a horizontal going across close to the ground, but we'll also have some extra poly, and what we'll end up doing is just shoveling some dirt right on top of it and sealing it up that way. So we'll also seal it on that bottom metal piece as well. And then we'll go ahead and probably somewhere, we'll have one at 11.5 feet. We'll probably split the difference and put another horizontal going across here. And then on this one we have a 48-inch square shutter. So what we'll end up doing is making something that looks like an H that will fit into there, and it'll be 48-inch square shutter, fits into a 48.5-inch square area. And we'll look at how we build one of those. And then again we'll just cover this way, cover that way, lock things in place. And then we'll do the similar thing down on the other end, except there's also, besides the can roll-up door at that end, there's a person door. So we'll have the same design in the middle and with the shutter. And then on one of these, we'll look at it. I think it's a 3 foot, but we'll open the directions and see how wide it is and what they tell us to frame out. So instead of having, we'll probably have, again, 3 sections, but we'll end up putting a door, probably I would guess in that corner over there. So we'll put a person door and then these 2 roll-up doors too.
Are those electric doors?
They're not electric doors, no.
Okay.
So I don't know of any houses that have had electric doors on them, but they're tensioning. So you can set, once you put them in, you can set the tension to them so that just like in a storage unit, when you raise it up, it won't, we won't set it so tight that it, goes whipping up, but we'll set it tight enough that it goes up pretty easily, and then there's some tension when you pull it down, but that it'll also pull down and stay in place, and then there's some interior locks that you can put in. So, and mostly, people usually put these on. Again, you could use them for ventilation. It's a big area, a big open space. If it gets really hot in the summer, throw the roll-up sides up. Put these can doors up too. Open up those shutters, which in this model are manually controlled, but you can also put them on thermostats and control them with that as well. So when you start opening the doors, the shutters, and the sides, you can really help to cool that down in the summer. So you can't run you can run the roll-up side. So this is a solar kit it's the first one we've ever done. It's the first one that Rimmel's done too. You can run those off solar because it's not constant draw. So it only is using electricity when it's moving up or down. For the shutters, it's on constant draw. So it has a motor on it, and it's not drawing when it's closed. But the way it works is this arm, the motors form as this little arm mechanism. And when they're open, it's a constant draw to keep that tension going, to keep those open. And so we can't generate enough, at least we are, generate enough solar to be that constant draw, especially, when they're open continuously and always pulling electricity. So, and I think if you do run electricity to them, they're like a 1/2 amp motor. So it's not like, they're a 5 amp motor. So it's not like, are they a 1/2 amp? I'll have to look when I get home. I think that they might be a 1/2 amp. Seems really small, but I think they might be a 1/2 amp motor. So they don't pull a whole lot. Yeah, the motor literally is about, the whole unit's about that big, so they don't pull a lot, but it is that constant draw that keeps it hard to, or not able to pull off of a solar one. So, it's about 6 o'clock. The plan was to go till about 6 o'clock today. I'm thinking about sticking around because it's sunny. And I want to make sure that we get plastic on this tomorrow. I'm thinking about sticking around and at least getting some of the verticals for this end wall in place and opening that box and seeing what the spacing is. People would be welcome to stay if they want. Please don't feel obligated. We're going to do the same thing tomorrow at that end, so you'll be able to see it, see how it goes together, see what happens. What would be nice is to have this one as close to finished as possible so that in the morning people can start putting the poly on this piece while we're working on that end piece, just to kind of get us rolling and moving and make sure that we do get a chance to cover it tomorrow.